Hi everybody, in this video we are going to talk about sectors. Isn't that great? Of course it is. Of course, there's probably one burning question you have, which is, well, what is a sector? Well, here it is. A sector of a circle is that portion of the interior of the circle intercepted by a central angle. So here is our central angle, here is the interior of our circle, and that is the sector. Now, one of the things that we might want to know about this sector is what is its area. And this is a convenient formula for us to figure that out. The area of a sector of a circle of radius r and central angle theta given in radians. Almost messed that up. Given in radians is equal to 1/2 r squared theta, or once again, theta is in radians. Now, I'm not going to prove this to you, but I'm at least going to show you that it makes sense, and I'm going to do that in the following slide. Okay, so what if that central angle has one complete revolution? Well, then its angle in radians is 2 pi, and its area is pi r squared. Okay, makes perfect sense. We knew that from geometry on years gone by. Well, what if the central angle was basically 1/2 of a revolution? In other words, 1/2 of a circle. Well, then we would expect the area to be 1/2 of this, and indeed it is. We get 1/2 pi r squared. If our central angle has a measure of 90 degrees, or pi over 2 radians, which is 1/4 of a circle, you guessed it, we end up getting 1/4 pi r squared. And if our central angle has a measure of pi over 4, 45 degrees, 1/8 of a circle, 1/8 of a revolution, then our area is 1/8 the total area of a circle. So yes, indeed, it does make out. And of course, we're going to be using this to solve certain problems. Problems like this one right here. We want to find the area of a circle having a radius of 15.20 feet and a central angle of 108 degrees. Of course, it's going to be in degrees and not radians, which means that we need to do extra work. The first thing we know, of course, is that our area is going to be equal to 1/2 r squared theta. And we know theta. Great. We know theta is 108 degrees. Of course, we need to have this in radians. So what we need to do is take this and multiply this by pi divided by 180. And if we do, we are going to get 0.6 pi. Now, if you wanted to, you could actually substitute a value in for pi and get something. I'm going to keep it in terms of pi for the time being. Okay, but nonetheless, this is our measure in radians, and of course we know that r is 15.20 feet. Okay, putting all this in, we are going to have that a is equal to 1/2 times 15.20 feet squared, and now our angle in radians is 0.6 pi. Okay, when we compute this, including our value for pi, we are going to get 217.75 feet squared. Now, since this has 2 decimal places and this only has 1, chances are if you had this in MML, they will want your answer down to 1 decimal place. So this will round to 217.8 square feet. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.